Welcome to The Explainer. Today, we're taking an exclusive, high-energy factory tour to uncover the step-by-step magic behind exactly how Skittles are made. We are going to break down the incredible engineering, the super-precise chemistry, and the massive, massive scale required to create one of the world's absolute favorite non-chocolate candies. Let's get right into it.
Here is a quick look at our roadmap for today. We've got 5 stops. 1. The Skittles phenomenon. 2. Mixing the chewy core. 3. Panning the hard shell. 4. Polishing and stamping. And finally 5. Quality control and packaging.
All right, stop number 1, the Skittles phenomenon.
To really understand this candy, you have to grasp the sheer, kind of mind-boggling scale of its global footprint. 70 billion. That is the staggering number of Skittles consumed globally every single year. I mean, to put that into perspective, if you line them all up, they'd wrap around the entire Earth more than 40 times. And to keep up with that totally insatiable demand, factories are literally pumping out 200 million of these little guys every single day.
So where did it all begin? Well, the story actually starts in England back in the 1970s with origins that are honestly a little forgotten today. But then Mars Incorporated took over in 1974, bringing it in as a fruity alternative to M&Ms. By 1982, it jumped across the pond to the US, opening a massive factory in Waco, Texas. Fast forward to 1994, and that completely iconic Taste the Rainbow slogan was born. Today, it's a global icon driving $1.2 billion in annual production. Just massive.
Moving right along to Section 2, Mixing the Chewy Core.
Now we're stepping right onto the factory floor to check out the actual chemistry. Every single day, the factory goes through 35,000 pounds of sugar. That is enough to fill a whole truck. They blend that sweet base perfectly in massive 5,000-pound kettles with a few core ingredients. You've got corn syrup for that thick texture, hydrogenated palm kernel oil, which is actually absolutely crucial because it softens the candy and stops it from drying out on the store shelf, and citric acid, which gives it that signature fruity tang.
Okay, but before we go any further, we really have to address the elephant in the room here. Do all Skittles taste exactly the same? You have definitely heard the viral internet rumor that all the colors have the exact same flavor and just use different smells to trick our brains, right? So, is that actually true?
Well, no. The myth is completely false. Strawberry, orange, lemon, lime, grape, they literally all get their own unique flavor combinations. Inside the factory, each specific flavor is mixed individually in its own industrial kettle with unique fruit juices and flavorings. From there, the mixture gets heated up into this thick, sticky paste that honestly looks a lot like really dense cake batter.
Next, that hot paste is poured into precise little molds to create what's known as a lentil, or sometimes called a pip. Basically, it's just a tiny, round, toffee-like pellet that forms the chewy core of the candy once it cools down. And here's the kicker. They have to be perfectly uniform in size. If they're not, the next step of the process just completely falls apart.
Which brings us to Section 3, Panning the hard shell.
This phase is kind of the climax of the whole factory tour. It's the agonizingly slow but totally fascinating process of getting that crunchy outer coating. It's a process called hard panning. Inside these absolutely massive rotating metal drums, called draggy pans, the lentils tumble around for hours and hours, and they go through 5 exact steps while being constantly sprayed with microscopic layers of sugar syrup. You've got gumming, engrossing, smoothing, adding the color coat, and finally polishing.
Get this, it takes an astonishing 43 individual layers of hard candy applied over a 6-hour marathon just to build that shell. During all this tumbling, blasts of air are blowing through to keep the candies from just sticking together into one giant glob. And by the time it's done, that crunchy little shell actually makes up 20% of the candy's total final weight.
All right, Section 4, Polishing and Stamping.
Once the shell is fully built, it's time for the finishing touches, where the candy gets its glossy shine. And the evolution of this shine is pretty wild. For decades, that shiny coat actually came from shellac. Yeah, literally a resin secreted by the lac bug. But no need to panic, because Mars made a major switch back in 2009. They moved to a completely vegetarian-friendly, food-grade wax polish. It tumbles in the drum right with the candies to protect the shell and keep those colors popping.
And you know, the formulation of the candy is still evolving today. For instance, a spokesperson for Mars Wrigley recently confirmed they removed titanium dioxide from their U.S. portfolio. That's an additive traditionally used to make the base colors look more opaque and white.
They made this change following similar regulatory shifts over in the European Union, which just shows how food manufacturers are continually updating their ingredient lists in response to various Health Commission reports and global safety standards.
Okay, now for the famous stamping. The polished candies get transferred to a massive belt that has 371,000 tiny little indentations to perfectly align every single piece. Then, a rubber roller coated in edible ink just zooms over them, printing the letter S hundreds of times a minute with absolute precision. It's a crazy balancing act. The machine has to apply the exact right amount of pressure. Press too hard and you crack a shell that took 6 hours to make. Press too soft and the letter smudges.
Speaking of that little stamped S, if you've ever dropped a Skittle into a glass of warm water, you might have seen something pretty incredible happen. Sure, the colors bleed out into a rainbow at the bottom, but the S? Well, the S does something totally different.
Here's the cool science behind that little party trick. That S is printed using what's called an insoluble edible ink, meaning it literally does not dissolve in water. So while the rest of the sugar shell and the waxy glaze completely melt away, the tiny little intact letter just peels right off the candy and floats all the way up to the surface of the glass. How cool is that?
Moving on to our final stop, Section 5, Quality Control and Packaging.
We're going from this slow, careful crafting process to lightning-fast, high-tech automation. First up, the 5 individual flavors finally meet. A massive blending belt is fed by individual hoppers to make sure there's a perfectly even mix of strawberry, orange, lemon, lime, and grape, or blackcurrant depending on where you live. So despite what the conspiracy theorists say about there always being way too many yellow ones in the bag, the distribution is actually engineered to be totally even.
But before they hit the bag, they have to pass one ultimate test. A highly sophisticated optical sorting system scans the line. We are talking about machines analyzing up to 2,000 individual Skittles every single second. 2,000! If any piece is too small, cracked, or even just a slightly off shade of color, it's immediately rejected with a tiny, ultra-precise blast of air.
From there, automated machines pack 50,000 bags every single hour. Giant rolls of plastic are formed into tubes, heat-sealed, filled with a precisely weighed portion of candy, and sealed up again, all ready to be boxed and shipped out to fans in over 65 countries worldwide.
It really is a beautifully complex process to make something that seems so wonderfully simple. As we wrap up this explainer on the incredible engineering and chemistry behind this tiny treat, I want to leave you with one final thought. If you had the keys to the factory for just one day, what wild, never-before-seen Skittles flavor or shape would you invent to add to the rainbow? Think about it. Thanks for exploring with us today, and I'll catch you on the next explainer.